2.2.5 Scope Management No Learning Objectives. This section considers how the translation of requirements into outputs for the chosen solution is achieved. There are a number of structures used that act as communication devices that allow a common perspective on the project to be gained by all interested stakeholders. By the time you have studied this section, you will have completed the following: Learning Outcome Assessment Criteria 5. Understand Project Scope Management. 5.1 Define the term Scope Management. 5.2 Differentiate between scope management within linear projects and scope management within iterative projects. 5.3 Describe how product breakdown structures PBS and work breakdown structures WBS are used to illustrate the required scope of work. 5.4 Outline how a project manager would use cost breakdown structures CBS, organizational breakdown structures OBS, and the responsibility assignment matrix RAM. 5.5 Define the terms configuration management and change control in the context of scope management. 5.6 Explain the relationship between change control and configuration management. 5.7 Outline the stages in a typical change control process. 5.8 Outline the activities in a typical configuration management process, including planning, identification, control, status accounting, and verification. Audit the term scope management. Scope is the term used in the management of projects to refer to the totality of the outputs, outcomes, and benefits, and the work required to produce them. Outputs deliverables are the tangible or intangible products typically delivered by a project. Outcomes are the changed circumstances or behavior that results from the use of an output and leads to realization of benefits. Scope management is the process whereby outputs, outcomes, and benefits are identified, defined, and controlled. A high-level scope is typically recorded in the business case in support of the chosen option and its investment appraisal. Scope management within linear and iterative projects. In projects with a linear life cycle, the baseline scope of work is defined through a breakdown structure to define the activities that will be scheduled and resourced to meet all the requirements and benefits. Scope definition in linear lifecycle projects is assumed to be fixed. The time, cost, and quality necessary to meet that scope is established in the remainder of the project planning process. In projects using an iterative lifecycle, it is equally important to structure the scope of work and record the assumptions. The difference in this scenario is that the must-have requirements are prioritized in user stories, and these are translated into a target scope of work, to be achieved within a fixed time window with defined resources. Subsequent iterations may alter the scope based on accumulated experience, acquired insights, and emerging priorities. Using product breakdown structures PBS and work breakdown structures WBS, to illustrate the required scope of work. The detailed scope of work emerges from the decomposition of the chosen option to meet the sponsor's requirements. Once a solution has been identified that meets the requirements, the scope of the work can be illustrated using a product breakdown structure PBS. Identifying both products and the work involved in building them is an iterative activity. Where uncertainty about the end products exists, provision must be made for revisiting the PBS and the resultant work breakdown structure WBS during the project life cycle. The PBS is a hierarchical structure, where the main output of the project is placed at the top level. The next level down shows the components that make up the higher level. This process continues to the level of individual products. Each product will have defined acceptance criteria and quality control methods. For example, if an organization wanted to organize an international conference, in order to market its products to new markets overseas, the initial PBS might look like the example shown in Figure 2. The PBS shows what will be delivered. There is no detail provided, as yet, about the actual work required to complete these deliverables. Figure 2.2.5.1 Example PBS for an international conference. Once the exercise of producing the PBS is complete, it can then be used to do initial scope verification, to obtain stakeholders' agreement that the products identified are what they expect the project to deliver and get a firm agreement to that effect. At this stage it is hoped that stakeholders would also advise on what products are in or out of scope. Scope verification will continue, at various points, throughout the project until the deliverables have been finally handed over and formally accepted by stakeholders. Clearly defining what is in and out of scope prevents the risk of misunderstandings at a later point in the project, which may lead to emerging issues and change requests. Incomplete scope definition is a common cause of time delays, cost growth and benefit reduction. Following the categorization of the project to create products, the project manager is able to direct those products to the most suitable technical resource for more detailed scope definition. This results in the baseline scope of work to be defined through a WBS, which will detail the activities that will be scheduled and resourced to meet all the requirements and benefits. The WBS derived from the example PBS shown in Figure 2.2.5.1 is shown in Figure 2.2.5.2. Figure 2.2.5.2 example WBS structure derived directly from the PBS at the lowest level of the WBS. Work packages will exist that contain the activities to be performed to allow estimating, scheduling and resource null assignments necessary to do the work and ultimately deliver the output. Where the objective is well understood and has a tangible output, e.g. in construction and engineering, it is usual to define the scope as accurately as possible at the beginning of the life cycle. Where the objective is less tangible, or subject to significant change, e.g. business change or Summit systems, a more flexible or iterative approach to scope is needed. How a project manager would use cost breakdown structures CBS, organizational breakdown structures OBS and the responsibility assignment matrix RAM in the WBS. Each work package will have a coded reference, in order to be tracked within the business management systems of the organization. Any estimated costs related to the delivery of that work package, such as people, equipment, materials or another resource required, can then be recorded using this coding structure. The resulting structure is the cost breakdown structure CBS, a hierarchical breakdown of a project into cost elements. The CBS provides a financial view of the project, and splits the project scope into its individual cost components, which can be related back to the original budget. The CBS will reflect the financial coding used for project accounting and any booking codes associated with each element of the project. The work packages in the WBS are reviewed and decisions are made about who in the project will take responsibility for carrying out the work, supervising activity and reporting progress. The structure of the project organization is vitally important for the effective performance of the activities, and to support the efforts of the whole project team. The organization breakdown structure OBS describes the structure of the project organization required to complete the work packages in the WBS. This is particularly useful when work will be performed by business staff seconded to the project or by specialist teams working on more than one project. It is also important for individuals themselves to know where they are situated in the structure and their reporting responsibilities. The WBS and OBS can be used in a combined way to create a communication device known as a responsibility assignment matrix RAM. This ensures that the people who are going to do the work are fully aware of the work they have been assigned, together with their position in the project organization. The functional line managers in the delivery organization would also consult the RAM to confirm the work that has been assigned to their people. There are resource management systems that can allow the functional manager to approve assignments depending on individual availability and departmental workload. A common coding structure can be applied to the RAM as shown in Figure 2.2.5.3. Figure 2.2.5.3 Responsibility Assignment Matrix RAM showing RACI coding. When the RAM is coded in this way, it can also be referred to as a RACI matrix. Are responsible, conducts the actual work, owns the problem, accountable, approves the completed work, and is held fully accountable for it, consulted, included in decision-making, primary supportive role, informed, kept informed of progress and results. The RAM provides a clear and concise summary of tasks or deliverables, the specific responsibilities defined within the project procedures, and the level of accountability or contribution expected from named roles or individuals within the project. The terms configuration management and change control in the context of scope management. Configuration management encompasses the technical and administrative activities concerned with the creation, maintenance, control change and quality control of the scope of work. A configuration consists of the functional and physical characteristics of the final deliverable, as defined in technical documents and achieved in the execution of project management plans. Change control is the process through which all requests to change the approved baseline of a project, program or portfolio are identified, evaluated and then approved, rejected or deferred. The relationship between change control and configuration management. Configuration management is very closely aligned with change control. There are two main points in the change control process, where configuration management will provide support. First, when a change is being assessed, those who are responsible for making the decision will depend on configuration management supplying the most current versions of the plans, documents or specifications necessary for assessment to take place. Status accounting will provide a record showing how each document has changed and the status of the current documentation being used. It will also show any interdependencies between configuration items, an important aspect when assessing any knock-on effects of change. The second point of support will be when the decision has been taken to implement a change. Once a change has been approved, all related documentation must be updated to reflect the change. The configuration record relating to all affected items will be updated accordingly. If any new changes are now being requested, configuration management will make sure that it is the updated version of all documentation that is released for review. The status of all previous versions will now be shown as superseded. Working together, these two processes ensure that deliverables meet the required specification, any changes are beneficial changes, and there is a complete audit trail for the development of each deliverable. Figure 2.2.5.4 shows the flow-through and relationship between those two processes. While the configuration is primarily concerned with the products of a project or program, it should also be applied to key management documents. For example, documents such as the business case and project management plan should be subject to version control and audit, to ensure that they are fit for purpose and all changes are recorded. As work is completed, responsibility for maintaining deliverables passes to business as usual. The project or program management team is responsible for ensuring that configuration management information is suitable for transfer to those who will be maintaining the products long after the project or program has been closed. Stages in a typical change control process. Change requests may arise as a result of issues that relate to the management of the work, or from external sources such as new stakeholder requirements, new regulations or changes in the context that result in the original plans being no longer viable. Managing requests for change effectively is a proven success factor in project management, the alternative being a potential escalation of problems, as changes are adopted without analysis of their impact on other parts of the solution or deliverables. It is of particular importance when the project is part of a larger program or portfolio, because the consequential effects of unmanaged change may be far-reaching within the planned change environment, and to business-as-usual activities. Managing change requests in a controlled way enables the sponsor and other stakeholders to understand the implications of variations on the forecast outcomes of the work, influence the decision on how to respond in the context of their objectives and appetite for risk. Figure 2.2.5.4 outlines the steps in a typical change control process. In scenarios where change is implemented without formal authorization, the project manager adopts a retrospective process, which is often seen as unnecessary bureaucracy. However, this is needed to enable realistic forecasts. Figure 2.2.5.4 stages in a typical change control process and relationship with configuration management. In certain circumstances, it is appropriate to implement a change freeze on a project, where no further changes are considered, as failing to do so would jeopardize the achievement of the project objectives. In some industries, Schedules of rates form the basis of pricing changes in advance of implementation. This eliminates the need to negotiate a price between contractor and client. Uncontrolled change in a contractual environment often leads to claims that may have to be settled in court. Agile projects make change control an integral part of the development process. Each development iteration starts with a planning meeting that clarifies and prioritizes the function addressed in the iteration. Some of these features may be changes to existing features, but these will still be considered alongside all the others. Activities in a typical configuration management process. At its simplest, configuration management involves version control of documents and information, but the discipline of configuration management is a more complex endeavor in projects, where the design of the solution is multifaceted, combining multiple technical disciplines and a wide range of asset types. The PBS, along with detailed descriptions of each product, becomes the project configuration. Once this is baseline, it is subject to formal change control and configuration management. The configuration management process shown in Figure 2.2.5.5 encompasses the following 5 activities: configuration management planning. A configuration management plan describes any project-specific procedures and the extent of their application. The plan also identifies roles and responsibilities for carrying out configuration management. The configuration management plan will often form part of the quality management plan, but may be separate in large or complex projects. Configuration identification. This involves breaking down the project into configuration items, and creating a unique numbering or referencing system for each type of item. For each item, a configuration record is created that will record the current version and subsequent changes to the item. Configuration control ensures that all changes to configuration items are controlled. As the previous step makes clear, it is important to identify the interrelationships between configuration items to enable this. Configuration status accounting provides records and reports that relate to a deliverable and its configuration information. It enables traceability of configuration items throughout their development. Users can consult the configuration record, which will provide an updated account of the status of the item, showing all changes to the current reference point, when these changes were made and who has taken responsibility for creating the latest version. Configuration verification audit. This is used to determine whether a deliverable conforms to its requirements and configuration information. At a minimum, a verification audit is undertaken at the end of a lifecycle phase, when a deliverable is finished or at the point of transitioning the output into use. However, audits could be carried out throughout the lifecycle during change control, to ensure management products are being used in line with their current configuration status. Figure 2.2.5.5 Activities involved in configuration management of an output. The key output of a controlled configuration management process is confidence that, since the current version of any configuration item is known, be that a document, drawing, software or another asset. Since document traceability exists between versions of each configuration item, think about a project that you are familiar with or one that you have researched and write down 5 ways in which the customer's requirements were established and controlled. How does this differ from the practices described in this section? 2.3 Achieving results. The results achieved will be proportional to the amount of upfront work described in this section and the previous section. Success involves controlling deployment and ensuring that there is good information about progress and performance. This informs correct action and decision-making to ensure that the business case is delivered as well as possible. It is also about rigor in the areas studied up to this point, such as issue management, change control, configuration management and quality control, to ensure that good work put into early life cycle planning is not squandered by a lack of attention to detail in implementation. Controlling deployment requires a detailed focus on monitoring and reporting, as well as a commitment to manage risk, issues and change variations in a disciplined way. The imperative to provide audit trails for assurance, and the opportunity for individual team members and the wider organizations involved to reflect, learn and improve, is an organizational reality for all who work in a competitive environment. In the final analysis, people deliver projects and strong relationships with people underpin the administrative and bureaucratic disciplines required during deployment. Ultimately, engaging and influencing stakeholders, forming, building and leading teams, and the generic skills and responsibilities of being a project professional are addressed with the objective of making it clear that all project-based work relies fundamentally on the ability of people to work together. Null.